what is going on in the experiment in order to answer the question. In fact, more often than not, you will not understand everything that is going on in the experiment. So don't worry about understanding the experiment. Just try to figure out what they're asking for and then get your answer, okay? So what they're trying to do here is show you is that ACT will test you on whether or not you understand what we call number behavior. So if one thing is happening in one variable, what's happening in the other variable? So look at trials 1 through 4. As the trials progress 1 through 4, what happened to force? Look at what happens to force in newtons. What happened? What would you say? Give me a vague conclusion. It increases. Very good. So as the trials went on through 1 through 4, then force increased. So it's they're asking you to look at number behavior. When this is happening, this is happening. Okay. Now, let's look at as trial 1 through 4 went, what happened to mass? Yeah, so mass increases as well. Look at table 2, okay? As the pesticide concentration, what happens to pesticide concentration in table 2 as the weeks go by? Does it increase only?
It varies.
Right, so your answer probably would be it increases and then decreases. That would probably be your answer. So one of the things science is often going to ask you to do, you will have at least probably 1 or 2 questions of this on every science section, is they're asking you to look at the charts and see if you can notice what the numbers are doing, how they are behaving. Okay, so let's practice on page 13. Everybody do questions 4 through 8 and see what you get. And then turn over to page 14 and work 9 through 14. So let's go 4 through 14 and then we'll go through them, okay? These are all practicing number behavior. So math and ACT is simple. They want you to estimate and round, okay? We've talked about locators telling you where and what to look for, right? And we've talked about the types of questions that we will have. Now we're going to talk about extrapolation and estimation. Anybody know what this word extrapolate means?
Does it mean to take out from the graph?
Yes, so it means to basically extend from the graph that you have, or to extrapolate basically means to extend beyond what is there. That's what extrapolate means. And then you are going to have to estimate. So here's what they are telling you. And I promise you on the ACT, you will have at least 1 or 2 questions that require you to extrapolate or estimate. And what I mean is when you have to extrapolate or estimate, they will give you a question and they will give you a graph. But in order to find the answer will not actually be on the graph. In order to find the answer, you will have to actually extend the graph and then estimate. Does that make sense? So they may give you a value, like if you look at this one on page 16, they give you a value of temperature up to 80. So they might ask you if the temperature was 90 degrees Celsius, what would happen to the solubility of NaCl? Okay, so look at that graph on page 16. They're asking you about solubility and temperature. It's representing solubility as it relates to temperature. And so if they asked you a question like, if the temperature was 90, what would the solubility be? So here's what you would have to do. It's your test booklet, so you would want to extrapolate. That means you would want to extend that graph. So if that graph goes to 80, and you've got this thing, and this is your cutoff, then you would kind of look and you would kind of guess, okay, it's about that far between 70 and 80, so it's about that far between 80 and 90. Go ahead and take your pencil, extend the graph, and then look at the trend of where it's going and estimate, and then try to get an answer. Okay, here at 90, it goes like that. That's the trend that it was on. So then you would look at your answer choices that were the closest to what you estimated. So there, you're going to have every single ACT, you're going to have a graph where they ask you a question that is not on the graph. Don't let that confuse you. Don't let it frustrate you. Don't let you think, oh my gosh, they've made a mistake writing the ACT. No, they're trying to get you to extrapolate and estimate. So what you need to do, get your pencil out, extrapolate, extend that graph and extend whatever trend you're seeing, and then estimate about what your answer should be and find your answer choice that matches. That makes sense? So that's what it means to extrapolate and to estimate. Extrapolate means to extend beyond what is there, and you're going to have to extrapolate the graphs and then estimate. You know what estimate means. All right, so everybody work now. Questions 16 through 20. On page 16, this should be relatively easy too, and I'm going to give you about 4 minutes. Okay, so look at page 16 and read for me. Let's just read all of it. Gracie, and read for me, and I'll stop you and tell you what to highlight.
Okay. There will be questions in the ACT science section that require you to extend the trend of a figure or table beyond its given boundaries. For line graphs, extend the line with your pencil to ensure the best estimation. The ACT is very good at anticipating incorrect answer choices that look correct when you only glance to extrapolate the line. All
right, so pause. Everybody highlight that. The ACT is very good at anticipating incorrect answer choices that look correct when you only glance to extrapolate the line, okay? So you really do need to extend that graph, okay? And try to figure out what the answer is, okay? All right, Gracie, keep going.
Okay. For tables or bar graphs, look for the best answer choice that fits your drawn estimation. The majority of these questions have only one answer choice that fits the correct range. For example, if you deduce that the correct answer should be between 1 centimeter or 4 centimeter, and there are 2 answer choices available in that range, you have likely done something wrong.
So if you think you have the answer and there are 2 answer choices, so let's highlight that last sentence. So if you think that you've got the answer and there are 2 answer choices there, then you've done something wrong. You need to go back and look at the graph, okay? All right, so for number 16, what did y'all get? Okay, so J and F. All right, so we need some practice at extrapolating. So let's look at figure 1 up here. It says, according to figure 1, at 90 degrees Celsius, the mass of NaNO3 that is soluble. All right, so NaNO3 is the little box one, right? And so we need to go 90. So you should have taken your pencil and drawn like another little almost 10. And then you should extend it, the NaCl, which is a little box line up, okay? So look at where that hits. Where does it hit? What's the solubility there? At 90.
H.
It is H. It is between 50 and 60. Does everybody see that? Okay, do you see why J is not wrong? And why, did somebody else say F? Okay, so that line is going up. So it's got to be above 40, but it's probably not up to 60. So H is the right answer, okay? All right, look at number 17. According to figure 1, at negative 10 degrees Celsius, the mass of NaCl that is soluble. All right, so NaCl is that solid line, right? And so you need to extrapolate on the left side of your graph to negative 10, right? And then if you go up to that line, what would your answer be? Which one fits? Logan, what did you put for 17?
I put D.
D is correct. Did everybody get D? Okay. All right, so now let's look at 18. According to figure 1, at 100, so now we've got to extend out even past where we did 90. At 100 degrees Celsius, the mass of HCl that is soluble in 100 milliliters of H2O. All right, so HCl is the diamond, and it is it's going up. So it's what answer choice did you get, Jack?
I had H.
H is correct. Did everybody else get H if you extrapolate there? All right, so it says, suppose trial 3 had been repeated with a block mass of 10 kilograms. According to table 1, the block speed measured would most likely have been. All right, so we got trial 3. And if we increased it from 8 to 10, we're looking at block speed of 2.4. So if there had been more mass, what do you think the answer would be? What'd you put for your answer, Eric, for 19? D, greater than 2.4, okay? Let's see if that, so we see that block mass, as it increases, block speed is increasing. So therefore, if at 8 it's going 2.4, we know at 10 it's going to be going greater than 2.4. Everybody see that answer? Okay, look at the last one. Suppose trial 4 had been repeated. So we look at trial 4, we have a block mass of 6, we have an incline of 40, and we have 3.7. All right, so if it had been repeated with an elevation of 35, and we see that as incline is increasing, then so is speed. So if it was less, if the speed was less, or the elevation was less, 35 degrees, what would the speed measured most likely have been? What'd you put, Sophie? F is correct, less than 3.7 meters per second. Okay, everybody understand? Okay. Now, data bridge, what I'm about to tell you is this is the most complicated concept in this chapter. It is one of the most complicated, I'm trying to make it bigger. I don't know that I am. It's really the most complicated concept really in science, but it will also help you a lot and you will need to use it a lot. So I want you to hang with me here. I'm gonna see if I can make it bigger. Look. Okay, so data bridge is a strategy that is going to help you in a particular circumstance. So everybody listen to, I want you eyes on me really quickly, okay? Data bridge is going to help you in a very specific circumstance. Everybody look at me, Jack, look at me, okay? You use this concept of a data bridge when the question asks you to look at multiple tables, okay? So you are going to know you need to apply this strategy when the question says, according to figures 1 and 2, or according to tables 1 and 2, okay? That automatically in your brain, you should go, oh, data bridge, okay? Now, what that means is, this is going to apply when you have, basically you have 2 graphs or 2 tables to look at, and they only have one thing in common, and that is what we call a data bridge. So look at these 2 graphs first on page 17. Look at what they're measuring, and look at what's on the x-axis, look at what's on the y-axis, and tell me, what do these 2 graphs have in common? What do they have in common? You can't, if you're looking up here at me now, you don't know. You gotta look down at page 18 or 17. Everybody look at, what do they have in common, Jack?
Whatever
EV is, right. So the questions are gonna tell us, I believe, that EV is voltage, okay? So you may want to even label, like when they have all these complicated variables, you might want to just label what they are. It might help you. So IMA is actually current, and then the little omega sign, that I believe is ohms. So it may help you. Okay, so here's what happens. When they ask you to look at two tables, usually those two tables are going to be measuring different things, but one of the variables is going to be the same. And you need to figure out what that is by looking at both of the graphs. That thing that is the same is what we call the data bridge. And what I mean by that is what they have in common. So it's going to bridge the two tables so you can find your answer, okay? There is a very specific process in doing this, okay? Your first step is to look at both of the graphs and to see what they have in common and to note what do they have in common. So I want you to write this somewhere on page 17 because this is the most confusing concept in this chapter. So your first step, when you need a data bridge, the first step is recognize you need the data bridge, okay? Recognize you need to employ the data bridge strategy, okay? How do I know I need to use the data bridge strategy? What's the question going to say? Anybody know? How do I know I need to use data bridge? So it will ask, the question will ask you to look at more than one table or graph. Okay? That's the first way you know, and I want everybody to write this down. You've got to know this. I'm going to test you on this. The ACT is going to test you on this. First thing you need to do is, how do I know I need to use the data bridge? Okay? Well, first thing is, the question's going to ask you to look at more than one table or graph. So you say, I need to use table. I need to use the data bridge. The second thing you need to do is figure out what the data bridge is. What is the data bridge? Somebody define data bridge for me. What is it, Jack?
It's the two things in the same on each table.
Yes, it's the variable that both tables have in common. So I'm going to write the data bridge is what both tables have in common. Okay. All right. Those are your first two steps. And it will happen like this. You read the question. It says, according to the figures 1 and 2, you say, oh, I need to use the data bridge. Then you go, look at both of them. What do they have in common? Okay. What variable do they both have in common? Now, here is how you figure out the answer. This part is harder than you think, but once you master it, it'll be so easy, okay? So 3. The first table you look at is the table that has the units that are in the question, okay? Look at the table that has the units mentioned in the question. Okay? Find the value. Okay? Then, I'm so running out of room. That's 3. And then the fourth thing you do is take the value. We're going to work on an example. You found in the first table and go to the table with the units in your answer choices. Okay, so there is very, very clear steps of how you do this, and I'm going to walk you through this, okay? First thing you do is you recognize you need to use the data bridge by seeing that the question's asking you to look at multiple tables. Second thing you do is you see what is the data bridge? What do both have in common? Then what you do is you go to the question, okay? And you're gonna look at the question. The question is gonna tell you where you need to look first by telling you what units are, it'll lead you to the table that has the units that are in the question. And then you're gonna find that value, and then you're going to go to the second table that has the answer choices. I hate that the bell is ringing. Give me 2 seconds, because we have another bell. Just give me 2 seconds, okay? Look at number 21. It says based on figures 1 and 2. Okay, so that's the first thing. It's telling us we need to data bridge. Does everybody understand? And it says when the resistance of device 2 is 3 ohms or 3 omega, the current I is approximately what? Okay, so which table has the ohms and the I in it? Which table, figure 1 or figure 2, has those two variables in it? Is it table 1 or 2? It's table, really? Yes, but which one has both of those? Huh? Neither. All right, so the table, which table has current in it? Table 1. All right, so we're going to start with table 1. So do you see, you look at the question, which one has one of those units that I'm looking for? So we're starting at table 1, and it tells us device 2. So look at device 2. It's the dotted line with the circle. All right, so find the dotted line with the circle, and it says when the resistance of device 2 is 3, the current I is approximately what? Okay, so we are actually going to have to go to, hang on. We are actually going to have to go to figure 2 because we are looking for 3 ohms, right? So everybody look at figure 2. It actually has ohms on that one, resistance. Do you see that? So go find resistance is 3 and then go find where device 2 hits 3. Okay, what is the voltage about when device 2 hits 3? Can anybody give me a value there? Y'all see what I'm talking about? 4. Is it 4 or is it, it's like 3.5. Okay. So now we have 3.5, and your answer choices say you're looking for MA. And so your answer is always going to be on the table that has that variable that are in the answer choices. So your answer is going to be in table 1. So now what you're going to do is you've gotten the voltage because that's your data bridge is 3.5. So go find device 2. Find its voltage where it's about 3.5, and now you can see what it is about what its current is, IMA. So at about what point is the voltage when it's 3.5? What would its current be on table 1 for device 2? 6. Yes, 6. So for 21, D is your answer. Does everybody see how I did that? It's really confusing, but once a light bulb goes off, you can understand it. Does that make sense? So you start with where you are in the table, what it gives you in the question, and then you find your value you need on that table, and then you go to the other table that has the answer choices. Does that make sense? Okay, we'll work on this again tomorrow. Your only homework for tonight is to review what we've talked about, okay? Got it?